The Solar Innovators Research Fellowship is training expert researchers who are PhD scholars, master's degree students, to research the viability of solar cell manufacturing in Africa. But not just solar cell manufacturing, the science, the conditions, and the considerations to know what to manufacture, what kind of solar cell works better for our climate in Africa. There are solar panels in Nigeria, silicon solar panels within Africa, which has been modeled according to the climatic conditions of Europe or China or wherever they are manufactured from. Of course, I know that probably there are some that were not as such, but none has been primarily optimized for Africa. And so that's why we are training African researchers to answer this question. We have 6 groups of fellows who are researching everything around the technology selection. What technology works better for us? Yes, we know that silicon might have market viability and, of course, commercial viability, but is it the best combination is it the best one for us? Right? And so one of our fellows have created this form. I'm going to work with you guys to answer the questions here so that you can see what we are really trying to check. This fellow is from Group 5, checking the economic viability of solar cell manufacturing. Group 1 is researching the technology selection and prototype development. Group 2 is looking at the manufacturing feasibility, thinking about all the equipment and the things that are needed. Group 3 is looking at the material sourcing. Where are the materials locally in Africa and in Nigeria that we can use for solar cell manufacturing? Group 4 is looking at the tropical and climatic considerations of Africa. For this research, our fellows are looking at Nigeria as a case study, right? And so Group 5 is looking at economic viability, and this person from Group 5 is the one that has created the form. Group 6 is looking at the go-to-market strategy. Who buys solar cells? Why do they buy solar cells? Why do they import from China? Why would they import from Europe? So in this first place, she has asked questions around trying to understand what the economic feasibility of solar manufacturing can be in Africa, right? In Nigeria. So we're going to take a look at that together. She wants to know in relation to imported solar cells, how can Nigeria fare? Like, will this be feasible in Nigeria at all? And so let's go. Over here, the first question is the dedicated industrial zones with electricity tariffs. Like, electricity cost is still a big issue in Nigeria, right? So, and solar cell manufacturing will take a lot of electricity. Now, with the tariffs currently at 206 naira per kilowatt hour, and per 225 kilowatt hour. So compared to approximately $0.065 per 0.7 kilowatt hour in other countries like China, how feasible it is in Nigeria to manufacture solar cells. And I'm going to answer here that it is moderately feasible. The reason is because solar can actually provide the power. So I'm going to answer here that because solar system for electricity generation, can provide 60% of the power. And I know this because we've already modeled this at the Reti Solar Assembly Factory. We know that we can generate 60% of power from renewables, but that is going to be very pricey. So we have a plan as well for raising the funds for that. But with that, I can say moderate. And the reason I say moderately is because other things will come into consideration, like policy levers aspects of things. The second question is around perovskite. Now, the adoption of perovskite silicon tandem, which is what most of our fellows are finding. I finished a very long call on Monday with Group 4, which is looking at tropical optimization and climatic considerations for solar cell manufacturing in Nigeria, right? We found that perovskite silicon tandem had 32% better chance than the existing silicon, which is 22%. So it has a 10% better chance. So perovskite silicon tandem, which is a mix, is emerging technology, but it does have challenges against it. But because of the challenges, we should not rule it out. Right now, this group 5 has already found the same conclusion as well that Group 4 found, and these groups are researching independently. So she mentions that because it has a higher efficiency, it has a potential to reduce manufacturing and system costs. And so the question is, how feasible is it for Nigeria to plan future solar cell manufacturing based on this next generation perovskite silicon tandem? This was my favorite question here because I myself had already arrived at these same conclusions. The only reason why some of the people in my group 4 team were still recommending silicon is because it has market viability. And I'm like, innovation thrives on discovering something new. Researching and asking the question, why has perovskite silicon tandem not yet achieved that market viability? What needs to be done or what needs to be set in place? So we should not rule it out because it is not being sold in market yet. There has to be an action, a set of rules, a set of policy, a set of premeditated plans and action strategy that will make it get to that point. So here I answered feasible. I had a temptation to say highly feasible. I just said feasible. And my reason is simply because we cannot attain innovation or discover new things if we do not create market opportunities for this technology mix. And here I mean perovskite silicon and tandem. Perovskite silicon tandem mix, because each draws from the super strength of each of the cells. Meanwhile, these 3 types of cells are also individual solar cells, right? But this recommendation here is recommending a mix, a full mix of one solar cell type that will bear properties of the three types of cells. So I believe that from research has shown that this mix is the best recommended ones. Our students in group 4 found that it was better for Nigeria, for Kano State precisely though, because of its specific climatic condition, and by proxy it will work very well for all the African especially northern African countries. And our group 4 has a task to as well find out what works for southern part of Nigeria. So the idea really is, why aren't we using the solar cells that work better for our environments and for our climatic considerations? So I'm going to go to the next one. Here it talks about volume, right? Volume and per unit. Solar panel manufacturing benefits from economics of scale, right? And so the key question is how feasible it is to achieve solar cell manufacturing scales. I think this question is very simple. Here the initial scale is 100 megawatt per year. How feasible? So how can, and again here you think again of the electricity considerations, which is quite intensive, and here you're going to think, how does that affect scale? For example, if you increase, for example, from 100 megawatts solar cell capacity manufacturing to, let's say, 5,000 megawatt, you're going to record a massive amount of raw materials for that, and you're going to need massive electricity. So how feasible is that? So here I'm going to really say I'm at a loss between moderately and low feasibility because of electricity conditions. So, but again, I mean, research is going on, and as we advance in research, other opportunities might become available in the near term. Like, let's say between now and 5 to 10 years, I still think it's moderately feasible to start with, let's say, 100 megawatts, right? But that big scale to 5,000 megawatt is what I would think is low feasibility because of conditions that might hinder that from happening. But for 50 to 100 megawatt, it's still feasible because solar power and clean energy can still help us meet electricity requirements that can bear that. So the next question is, I think that was how feasible it is for Nigeria to achieve this gigawatt production. Okay, this was the question. Sorry. This was the question where I was saying moderately feasible. This was where I was saying low feasibility, because I'm talking like from 20 years. I'm talking that between now and 5 to 10 years, this guy here is still feasible, but between 20 years above, I think it's going to get some moderately feasible. Oh my God. But from now, I think the feasibility is still low because of the requirement. Why did you give this rating? I just said it now though. So I'm going to say, simply because we have not attained required growth in electrification. that can bear gigawatt reach. Also, there are other things around policy. Is there even political will for gigawatt manufacturing reach? And what policies support solar cell manufacturing? That's what I will say. I know that for this shorter scale, production, the Energy Transition Plan of Nigeria makes some provision for, some few ideas around manufacturing, but not quite specific. So I'll go to the next one. Here it says assessing loan and grants and funding for solar cell manufacturing. How feasible is it for solar cell manufacturing in Nigeria to gain green climate conscious? So feasible. I would say it's very feasible because of the recently launched African Solar Manufacturing Initiative, RME, African Renewable Energy Manufacturing Initiative, RME, by the Sustainable Energy for All, which I first became aware 2 years ago. So there is policy, there is plans in place. The United Nations is involved in thinking about it because of the UN Sustainable Energy SE for all. So that policy alone, that plan, it makes available these types of funding. The Global Energy Alliance for People and Planets is also fully involved in the RME initiative, and I know that they are having these important conversations around pulling funds that will support manufacturing. Also, the Africa Development Bank, the African Union, these are people that I know that are thinking about it. Now, the Solar Innovators Research Fellowship Program. I'll say RME initiative. I think my video now is very long. I hope I'll be able to post all. RME initiative makes... Okay, I forgot my word for it. I will just say RME initiative. So I'll talk about African Union specific. Oh, that is ECOWAS Union. I still have a lot more questions. Battery storage for shifting or grid arbitrage to reduce electricity cost. So for solar cell, I think it's feasible because but cost though, it is okay. I'm going to say moderately because cost just makes it a little bit harder. So here I'll say, of course, battery, because if we're going to use solar power to store some of the electricity, we're going to need minimal battery storage because the factory will operate two shifts of 16 hours. Would that work? So say 9 to 5 p.m. Okay, so one full shift of 8 hours from 9 to 5 p.m. where solar is still fully available. And there, for nighttime usage though, we might then consider additional battery storage. For the model that we did for Reti Solar Factory, we found out that we will be able to only originally start from just having running wash shift from 9 to 5 p.m. a day, and we can, when the factory grows, we can now do a full battery system for nighttime shift. But for now, we can use a little bit of battery capacity size for the daytime use, just to give it a regulation, to regulate it. Here I would say yes for... Okay, I'm going to get back to this. I need to just finish this video. Okay, so yeah, that's really what it is. Here, cost reduction measures, blah, 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 blah. Additional cost. So I'm going to finish it up. I'm going to submit though, but I would say this here. The Solar Innovators Research Fellowship is working with the ECOWAS Commission, ECOWAS ECRI, Renewable Energy and Energy Efficiency Initiative, to support the Solar Innovators Research Fellowship. And part of our plans is to be able to share what we're finding out from this research. Our program is 4 months old, but the way we have seen it's going to really exceed much more than that. These conversations are important. I'm going to do another video for you to explain what the findings of group 4 in our research. On Monday, every Monday our groups defend their research, and on Monday I spent 5 hours talking to the fellows, and they are really breaking the ground open. There's really a lot they're learning, because you can't just go into solar manufacturing blindly. What are you going to manufacture? Which cells work better for Africa or Nigeria? You have to ask these questions and know. And to my knowledge, I've not seen any research that answers these questions specifically down to cities in Nigeria, down to cities and countries within Africa, right? There's always been general recommendations, but none that has really, really quite narrowed it down like this. So if you'd like to partner with the SIRF program, or you'd like to support one of our fellow groups to improve their research or to, do something big to really innovate around it, feel free to reach out. We're also searching for partner labs around Africa for where our fellow